Okay, so this is lesson 6.1, operations on functions. It's MA 912.F.32 and MA 912.F. So some operations on functions. So we have our addition, subtraction, multiplication, division properties. If we see f plus g of x, you can separate it into two individual pieces of f of x plus g of x. When we do subtraction, again, if it says f minus g with an x on the outside, split them up into two individual pieces, f of x minus the g of x. Multiplication, if we see f dot g with an x, it means we're saying f of x times the g of x. If we see the word division and we see f over g, you're just going to write f of x over the g of x. Now, the one thing about division property is that the denominator cannot equal 0. So basically what we're going to do is, back in the previous times we did this, we're looking for our domain values. What values can x not be to influence our problem? In example 1, it says add and subtract functions. So it says, given f of x equaling negative x squared plus 3x plus 1, and the g of x is 2x squared minus 5, find each function. So the first one they want us to do is find f plus g of x. So what we're doing is we're rewriting it as f of x plus our g of x. So then I use substitution. This is what we did. We're substituting our values. In for our pieces. So we substituted negative x squared plus 3x plus 1 for f of x and 2x squared minus 5 for the g of x. And then it's because we have a plus between the things, we're going to add our pieces together. So we broke everything out. So we have negative x squared plus 3x plus 1 plus 2x squared minus 5. We're combining like terms now. So first thing we see when we're combining like terms, I see a negative x squared and positive 2x squared. That's where we get our x squared. The next term grouping we see is I had $3 of x and that's it. So my 3x stayed. Okay, so we're combining like terms. I see negative x squared plus 2x squared. That gives me my x squared. We then see I have 3x. There's only one of them, so I stay 3x. And then we have $1, but we spent 5. So 1 minus my 5 makes it a negative 4. And there's our final product, which is x squared plus 3x minus 4. Okay, on f minus g of x, so we're going to isolate first by rewriting it as f of x minus the g of x. We're going to substitute in for f, and our problem originally was negative x squared plus 3x plus 1. So we're going to write in negative x squared plus 3x plus 1 minus, and there's our g of x. Now remember, distributive property means that you need to distribute that minus sign to both parts, and that's where we have negative x squared plus 3x plus 1 minus a 2x squared. Now negative makes it positive 5. Okay, again, we're combining our like terms. So we see negative x squared and our negative 2x squared, where that gives us our negative 3x squared. We have 3x is by itself, so we're still a 3x. Then we see we had $1, but now instead of losing 5, we gained 5. So 1 plus the 5 makes it a 6, resulting in negative 3x squared plus 3x plus 6. Now in example 2, it says multiply and divide. So they're giving us f of x equaling 4x squared minus 2x plus 3, and g of x is negative x plus 5, and they want us to find each function. So the first one they want us to do is f dot g of x. So remember, we're going to isolate it and write it as f of x times g of x. So we're going to write 4x squared minus 2x plus 3, and inside the g of x bubble is now going to be negative x plus 5. At this point, I'm actually going to the side because I'm going to use the box method. So we have our 4x squared minus 2x plus 3, and we're multiplying it by our negative x plus 5. So let me erase that last line right down here. So when we multiply in, remember we're multiplying diagonally for our pieces. So we're saying negative x times the 4, that's negative 4x cubed. Negative x times negative 2 makes it positive 2x squared. Negative x times 3, it's negative 3x. 5 times the 4, that is 20x squared. 5 times the negative 2 is negative 10x. And 5 times the 3 is our 15. So when we look down here, negative 4x cubed, it checks. Then the next one is going to be the first x squared, so I'm going to write positive 2x squared. And it's going to be the next x squared, which is a 20, which is right below it. Then we see our negative 10x, and we have a negative 3x, and then our positive 15. At this point, we're going to combine our like terms. So negative 4x cubed is the only one, so that's why it stays negative 4x cubed. The next group down is going to be our x squared, so we have 2x squared with another 20, making it 22. Then we see our negative 10x, and we spent another 3 we didn't have. We're at negative 13x, and then our positive 15. On the division one, it says f of g of x. So remember, as you're writing the f of x over the g of x. So we wrote 4x squared minus 2x plus 3 over negative x plus 5. Okay, so remember, we're doing our restrictions for our domain. So we're looking at our denominator. So you're taking your denominator and saying negative x plus 5 equal to 0. I'm adding x over. So we get 5 is equivalent to x. So remember, your restrictions are all the values of x that the denominator cannot be. In this instance, that can be any number except 5. Okay, in example 3, they want us to interpret a word problem. It says the population in millions of India T years after 1955 can be modeled as a linear function, which is f of t equaling 15.7t plus 3.44. T.2, and the population of the United States can be modeled also by another linear function, t years after 1955, which is g of t equaling 2.6t plus 165.8. They want us to define and graph the function that represents how much greater India's population, and here's the phrase, how much greater India's population is than that of the US. So it says step 1, identify the function operation. So because the question asks for how much greater India is over the US, where it's defined by subtracting g of x from f of x. In this instance, actually g of t from f of t. Okay, so in step 2, it says write the combined function. So they want us to do f minus g of t. So again, that's the f of t problem minus the g of t problem. So then we wrote the 15.7t plus 344.2 minus, and then in parentheses, notice that we use parentheses, we put in the 2.6t plus 165.8. Remember, because it's a minus sign, we have to distribute our pieces. So they're saying 15.7t minus 2.6t. That's where we get our 13.1t. And then we see 344.2 minus our 165.8. And that's where we get our 178.4 for our final solution piece. When it asks us to graph the function, in this instance, I would use reverse and use Desmos and type in y equals our equation that we just came up with, but instead of a t, in Desmos, you're going to write 13.1x plus 178.4. Remember, Desmos tends to work more in x's and y's, so for graphing purposes, that's what you would use. To determine the domain and range of the combined function, because f of t and g of t are modeled for t years after 1955, the domain, it has to be restricted for t values greater than or equal to 1. So in this instance, the range, now in step 4, it says determine the domain and range of the combined function. So because f of t and g of t are modeled years after 1955, we're going to say the domain is going to be restricted to values of t greater than or equal to 0. Your range is where the lowest y value could be, which is greater than or equal to 178.4. In example 5, they want us to compose functions. So in order to compose functions, you need to know what fog and goff means. So if you see f o g of x, that's the same thing as saying f of g of x. If you see Goff, which is g of f of x, that's saying g of f of x in parentheses. So they want us to first find, they gave us a given function that says f of x equals 2x minus 5, and the g of x is 3x. So they want us to in part A find f of g and then g of f. So f of g, remember, is g of f of g of x. So I'm saying f of, and the g of x equation is 3x. So then I take the f equation, in this instance it's 2, so I'm saying 2 times a bubble minus 5. And in that bubble I wrote 3x. So 2 times 3 is 6x minus 5. Then we go to our g of f, or Goff, g of f of x. So I'm saying g of, and then in parentheses I'm writing the f of x equation, which is 2x minus 5. The g equation, remember, it was a 3, so I'm saying 3 times that bubble of 2x minus 5. We're distributing, so 3 times a 2 is 6x. 3 times a 5 is negative 15. That's where we get 2x minus 15. So when they ask us to state the domain and range, we need to remember that because both f of g and g of f are both linear functions, our domain is going to be all real numbers. Our range is also going to be all real numbers. Remember, linear functions is the format of y equals mx plus b. And we know from previous lessons that the domain is going to be negative infinity to positive infinity, or XER.